Welcome to Mastering Machines, where we discover tomorrow's reality.
Hey everyone, welcome back to Mastering Machines. Today we're diving into a fascinating paper titled AI Agents for Computer Use, a Review of Instruction-Based Computer Control, GUI Automation and Operator Assistance. This paper, authored by Pascal Sagard and a team of researchers, explores how AI agents are revolutionizing the way we interact with computers. So whether you're a tech enthusiast and somebody that's really from the AI community, or even somebody who's just kind of out of the loop and just uses ChatGPT in their regular life, this will be something that's useful for you. These agents, called instruction-based computer control agents, can perform tasks on computers by following natural language instructions. Think of it like having a virtual assistant that can click, type, and navigate just like you would on a regular computer. The paper reviews 86 agents in 33 data sets, and it shows how we've come really far in the AI agent field and industry. Early CCAs were designed for specific tasks, like filling out forms or navigating websites. But now, thanks to foundational models like LLMs and VLMs, which is vision language models, we're seeing a shift toward more general purpose agents that can handle a wide range of tasks across different domains like web browsing, Android apps, and even desktop applications. One of the most interesting things of the paper is this 3 perspectives of CCAs. It talks about a taxonomy to analyze CCAs from these 3 angles. It's first, the environment perspective. What kind of computer environment is the agent operating in? 2, interaction perspective. How does the agent observe and act within that environment? And then number 3 is the agent perspective. How does the agent learn and make decisions? And this framework is super useful, and it helps researchers compare and improve different agents. In the paper, they also talk about how agents view and interact with things. And 2 of the main ways that they do this is via text or images. So in the paper, they talk about textual representation, so it's like HTML or Android view hierarchy, or image representations, which is screenshots of that actual screen or computer. Interestingly enough, while text-based agents were dominant early on in the history of agents, recent advancements in vision models are making image-based agents more powerful, especially in the real-world scenarios where HTML can be, kind of messy or inconsistent. That's why you see a lot of different AI agents that can create an app or a website based off of a screenshot. One of the other elements of agents that you really have to consider is that agents interact with computers through actions, and actions are key. So these actions like mouse clicks, keyboard inputs, or even direct UI access to a website or app, you have to use these tailored actions like, sending an email or actually clicking send email. While others rely on, executable code to perform these complex tasks, the choice of action space depends on the task and the environment, and that's going to determine how you use your AI agent. Another thing with agents is that you have to make certain that they have some type of learning strategy. So typically it's broken down into these 3 types. You have general pre-training, so that's learning broad skills from large data sets. So that's what you see with a lot of foundational models sometimes. Then you have environment learning, adapting to specific computer environments through reinforcement learning or behavioral cloning. And then also you have the episodic improvement, refining their performance with a single task using techniques like instruction tuning or a few shot learning. This multi-step learning process is what makes these agents so versatile that they use all 3. And this field is really growing. The number of publications on CCAs has skyrocketed in the past couple of years, especially after the rise of foundational AI models such as GPT-4. This shows how much potential agents have and how they're going to basically be a building block of the future. But there are a lot of challenges ahead. While CCAs are impressive, there's still a lot of hurdles to get over, even in this current environment. So one thing that they have a lot to work on is the actual environment learning. How can agents efficiently efficiently adapt to new environments without extensive training. That's going to be the kind of next use case for the next generation of agents. Then planning. Agents need to get better about planning and breaking down complex tasks and completing them and understanding all the smaller steps in between it. Then also the fact that you need safety and privacy. Ensuring agents don't make harmful mistakes or expose sensitive data is necessary. These challenges are critical for deploying CCAs in real-world applications. This paper predicts that by 2027, we'll see AI agents that can act as true personal assistants, learning from our interactions with devices. Imagine an AI that not only helps you with different tasks, but also adapts to your different preferences on the fly. The potential is very huge, and it has the possibility of becoming a huge market, but it also has a lot of questions that raise about it when it comes to privacy and trust. This is a great paper to take a look at and really understand where the next generation of technology is going to be and how it's going to work with AI agents and how they're going to literally be the new digital workforce. So remember, master machines, discover tomorrow's reality.